Okay, Assalamualaikum warahmatullahi wabarakatuh. Good evening, everyone. In this technical drawing video, I'd like to make a test point and grabber file PCB on KiCad as instruction neatly. So let's explain with English about my PCB. I will record in minimum 10 minutes and upload it on YouTube. So let's go ahead to KiCad. So this is the current PCB that we are going to send into Spectra for the printing. No, it should be on the other file. So let's just go ahead and open my PCB. I will just open here. So this is my PCB. I will explain it right now. So here we are. This is the 3D design, as you can see, with my name with it. And let's see the just jump right here. So this is my ESP. So I split this into 4 sections. Here we have the power regulator module with the USB-B to import data. This is the jack port, barrel jack to import the required voltage. Here I have the power pins in case of emergency to jumper or power up the PCB. This will be the switch. This is the LED power. It acts as an indicator if the power is connected or there is power running on the PCB. There is also the power. Yeah, I guess it's 412 volt. This is the diode for safety. This is the fuselage for the power regulator. This is also the diode. And there are 4 test points here. We have the ground, 3 by 3, I guess 3.3 voltage to check whether it's working or not. There's also a 5 volt PCB test points. There are 4 regulators here, as you can see. It acts as a power capacitor, so it won't overload the ESP with the high voltage that runs through the input power. Well, here is my ESP32. Next, on the right side is the reset button. It acts to reset the program that I have been uploaded. There's also the VS2812B RGB LED. We could control it using the ESP later. This is the I2C port. It acts as a port for LCD module. There's also the temperature. It acts as a port for sensor input later. There's also room for another sensor. It's for turbidity. There's also a serial port to communicate with other module or other components. I already placed a 5 volt for servo in case the 3 voltage couldn't handle it. Well, what I will make is a simple system to control the perfect environment for the fish in a bowl or fish on an aquarium. Well, I will do this on my betta fish later. I will buy it first, then I will check it with the room temperature and turbidity. So later it will display on the LCD the data that I've been uploaded into ESP. If you are wondering how is the backside, oh wait, so the servo will act as I don't know, filter to move the filter, I guess. So there will be a switch, or we could use the relay, or we can use the servo as the shade if it's too warm for the fish. And the turbidity to check if whether the water quality is bad or not. Let's flip to the other side. Here is on the back side the logo, the name and student number. Here's my routing. A bit complicated on here, but I'm pretty sure it runs well. I hope. This is the capacitor for the ESP, and this is the capacitor for the servo. There's also a capacitor for the put button. Also to an amount of resistor here also. There's also a capacitor for the CH340C module. It acts as a telecommunication. There is also MMBT2222A with a set of resistor. So here's how do I make the test point after we see the design of my circuit. Wait, there it is. So first of all, I will go to the schematic and insert symbol using a shortcut. Press A to the shortcut. So it's okay. It's not a big problem. Still loading. While we're waiting, we could see the design again. So it's my routing. A bit laggy, I guess. Wait, something happened. Okay, it's done. So we can just search for test point. Here we go. Drop it elsewhere where there is a voltage to see the current. And the voltage I used to drop here, but you can just drop it here. Press R to rotate. Drop the test points. Also here for the grounding. Here we go. Press it. Select the footprint. We can press E on the shortcut. Use the test point to test the voltage. Let's say the in value. Let it be the test point, or we can TP5 for test point 5 stands for test point 5. You can see the test point. If you're wondering what would your test point looks like in the design, we can just click here for the 3D. Yes, I guess. So this is the reference. This one is with a hook, so you will buy another component in order to run the test point. I will not use this since it will cost me more budget. There's also the one with a hook like this and safety. I'll just use this, the test point pad. Or we could use the circle one, the size of 3mm. I guess it's enough. Press OK. You can just duplicate this and switch with this one, so I won't have to do search for the library. Delete. Rename TP6. It's for the ground. We can go to the DZ, the 3D design. Update PCB from schematic. Update PCB. So here we have the 2 more test points. Should be connect right into here and also here for the ground. So we connect them. It took more space, so I should allocate them here. And for the ground, here. It's just for the demonstration. So let's connect using X, reroute using V for the via, another V, no wait. Here should be fine. And for the grounding, we could press V again and connect. And here we have another 2 test points. I guess it looks good. Should be fine. So what is the urgency to add the test point on the PCB? So it will act as an indicator if the voltage and current is there. So we can use the multimeter, more exactly the multimeter's probe, the one with the red and black cable. I'll just stick my red multimeter probe here to check the ground, I guess, and here for the grounding. I'll just tap and see the readings on the multimeter, so I know if it's safe or not. Here I use the feature fillet to make the edge a bit round so it won't damage the user that will touch or solder it. Here's my design. It's my first time, so I hope it's good. We can see here the inductor for safety from the power regulator, or exactly the 3x3 3.3 input power regulator. So this is the inductor. We have here the fuse, polyfuse, the small one. We have here the let's see, D2 for the diode zener, so the current won't be running back on the 2 sides, so make sure the current is only one way. Here's the communication module. Yes. Here we have the power regulator for the 5 voltage. I add this for safety, so if I want to use the power voltage input, I could just stick my connector here. And so the power capacitor will hold the power. And here we have the switch. Yep, we have the whole sets of 3x3 volt power regulator module. So it should be here, here, and here. It's the inductor, the what's this called? LM2596S 3x3. This is the diode, the polyfuse that I have been talking about. We could see the back side. Also there is the resistor. I use the resistor for the safety. The resistor go to the LED, so it won't make the LED explode if the current is too high. Here's the IO4 pin that I use for the sensor. I use the IO6 for the turbidity sensor. I use the 1017 and 1018 for the serial ports, so it will communicate with other module. The ground here, 3 volts. The I2C port here use the IO8 and IO9 for communication. Why? Because it is already taught in the datasheet of the ESP. Let's go ahead to the datasheet to make sure if all the components, if all the pin is right. So here IO4, make sure it is ADC. ADC means analog digital converter. Same goes with IO6. And for the IO, what was that? IO17? No. IO8 and IO9, I use the GPIO, RTC, so it will communicate. Okay, just go to do random nerd tutorials for the pinout. So here we go, we have it here. It's for SD1, SHD, and other goes to 17 and 18. Here we go. UART, transceiver, receiver, can be assigned to other GPIO. So this was my first PCB. Okay, thank you for listening to my presentation. I'm sure it will work. I'm pretty sure. Okay, thank you, and see you next time. Okay, so I will upload the Gerber file. Let's select the current project. Here you go. Go to PCB editor. So here we have the design. Okay, let's go ahead to file. Click the fabrication output. There are lots of files. Click the Gerbers. You go to generate drills. Here is the folder. Select first. I will go with this, make the new one here as a test. So it's no, just drop it here. Select folder. Yes, we go to generate. Done. Close. Then go plot. Close. I think the file should be here. Elsewhere. Ah, here we have it. Exact date and time. We could just make it into zip. Send to spectra. To fabricate, could just select all the current folder, cut, send it to, wait, I made a mistake. So we could just here, right click, no, right click, compress the zip file, should be like this. Rename, okay. No, I made a mistake. Let's delete. I'll just show you the examples so to make it easier. Compress the zip file. Okay. Now we have all them in the OK file. So that's it. Thank you, and see you next time.